Hello, I'm William Johns. I'm attending the University of Advancing Technology under Professor David Bowman. I'm presenting a presentation for Team 3 on a course from Technology Forecasting and Change Management. Um, the topic is going to be Emerging Technologies for the State School Board, AI Teaching Assistance, Workload Reduction, and Compliance Support, a Technology Forecast. And we are acting as technology directors for the Office of the Chief Information Officer, and I am accompanied by Daryl Martin, Michael LeBlanc, and Renee Wiley. Today is August 12th, 2026. The agenda for today will be to look over the technology director's opening questions, and then we're going to basically uh, present to the school board a problem framing through technical analyses to an honest organizational self-assessment, ending with a clear bridge to the next phase of work, a change management and implementation plan. Uh, in order to do this, we're going to talk through the framework in some analytical terms, and I'm going to give you some updates and some explanations for that. Uh, that'll be actually S curves, hype cycles, innovation adoption curves, fusion, speciation, and convergence. Now we're going to go through these terms and you'll have a basic understanding of those such that when we talk about the 5 technologies under review, you'll have an understanding as to the meaningfulness of those metrics. We're going to do a current state assessment for each technology. We're also going to look at market viability forecasts and assess the value networks, domains, and evolutionary classifications. We're going to match solutions to lifestyle stages and look at organizational readiness. So you may ask yourself, why does this matter at this point in time? Teacher workload is at an all-time high. Administrative tasks consume an estimated 30 to 50% of educator time. And this definitely takes away from teachers being able to actually teach their students, which is oftentimes why teachers went into the field in the first place. They wanted to teach and be part of the change revolution and educate who's up and coming, but a lot of times they're bogged down with paperwork, compliance, and multiple competing demands. Students need more individualized support than a single teacher can deliver at scale. My niece is a teacher, heard a lot of the perils of being a teacher at this point in time and the amount of paperwork and overload that's is quite consuming. Other people on our team are also in the educational sector, and they also did that information and then some. We must first define the data privacy and student data governance interoperability with existing learning management systems, or SIS, and total cost of ownership. Also, equity of access, staff training capacity, and the legal compliance exposure, FERPA, and student data or state student data laws. This session frames 5 current EdTech AI vendor families and forecasts the next generation of technologies that could fill the same organizational needs. The analytical framework that I was speaking of earlier, the S curve. The S curve is very important. It looks at the technology capability and adoption and follows a slow start, rapid inflection, then a maturity plateau. More specifically, the technology S curve describes how a technology's capability and market adoption typically progress over time. A slow start during the early research and development, a rapid inflection once product market fit is found, and an eventual plateau as the technology matures and diffusion saturates the addressable market. The next thing we're going to talk about metric would be the Gartner hype cycle. It offers a complementary expectation-based view, moving through 5 phases. That would be the innovation trigger, when a breakthrough or launch generates initial excitement. The peak of inflated expectation, when usage grows faster than proof of value. The trough of disillusionment, when in early implementations reveal limitations and the enthusiasm cools. The slope of enlightenment, when second and third generation products demonstrate real well understood benefits, and the plateau of productivity, when mainstream adoption and clear return of investment take hold. The third model is the innovation adoption curve postulated by Rogers. And this describes adopting a technology rather than how mature or hyped it is. Rogers segments the population of potential adopters into 5 groups along a normal distribution. You have the innovators, roughly the first 2.5% of that curve, who take on risk or try unproven technology. The next would be the early adopters, 13.5%, who are influential and adopt once initial value is demonstrated. You have the early majority, 34%, pragmatic adopters who wait for proof but adopt before the technology is fully mainstream. You have the late majority, 34%, who are skeptical adopters who wait until the technology is well established or effectively required. The last group is the laggards, the final 16% who adapt last, often only when a technology becomes unavoidable. We're also going to look at the value networks, which is the web of suppliers, partners, distribution channels, and customers that determine how a technology captures value. And we'll talk some on market domains. Evolutionary patterns will also be discussed, and these break down into either fusion, speciation, or convergence. Fusion happens in many products in the early life cycles, many things that we used throughout our time periods of our lives, such as, say, influential technology devices such as the computer. That was largely a fusion pattern that took place to create a computer, the first computers. 2 or more technologies combined to create a capability that none could achieve by themselves. Speciation is when a technology branches into specialized versions for different audiences or use cases. We're also going to look at when any of the technologies that we're assessing here have a convergence pattern, which is when multiple technologies merge into a unified system while each base technology remains intact. The 5 technologies under review. We're going to be looking at Brisk Teaching, which is an AI teaching and curriculum assistant, which is a series of Chrome extensions. There's also a software program called GoGuardian, which is a classroom management and internet safety platform, including its subsidiary PeerDeck, which is an interactive lesson and formative assessment tool. We're also going to take a look at IXL Learning, which is an adaptive AI-driven math and multi-subject practice platform. Also, we're going to assess and take a close look at Microsoft Copilot, which is AI layered into Microsoft 365 productivity tools. Also, lastly, we're going to look at ChatGPT and cloud. ChatGPT is an open AI product. Cloud is from Anthropic. These are general purpose and safety focused LLMs, which is large language models, speciated and fused for educational use cases. So first of all, we're going to look at Brisk Teaching. The current state of Brisk Teaching software as far as S-curve and hype cycle positions are concerned. Just a little background first. Brisk Teaching was launched in 2023. It's a Chrome extension embedding 30 plus AI tools directly into Google Docs, Slides, Canvas, and Schoology. They've recently surpassed 2 million educators, and they had raised $15 million in a Series A funding by Bessemer Venture Partners in March 2025. plus a $5 million seed totaling $21.9 million. Their S-curve position is early growth phase, just past the inflection point. There's rapid teacher adoption, but generative AI feature set is still maturing. Their hype cycle position is that of a peak of inflated expectations. There's strong enthusiasm, and usage growth outpaces independent longitudinal evidence of learning impact at this time. Brisk Teaching, as far as innovation adoption curve position, again by Rogers. The innovation adoption curve position is crossing from early adopters into the early majority. There's approximately 2 million plus educators, indicating that the tool has moved past enthusiastic teachers into mainstream classroom use, but the district level majority institution adoption is still forming. The individual teacher first go-to-market strategy is a classic early adopter entry point, and this is typical of tools that later cross the chasm into early majority by a bottom-up grassroots demand rather than top-down district mandate. Risk for this is that tools stuck with only early adopters can stall before crossing into the early or late majority if, in fact, the independent efficacy evidence does not materialize in a meaningful way. Risk teaching in regards to market viability forecasts and applications. We feel this is market viable for district-wide procurement now for lesson and rubric drafting, district management, and analytics features projected to mature in the next 12 to 24 months. Product applications, auto-aligned lesson plans, rubrics, worksheets, quizzes, differentiated materials, and writing feedback. The process applications for this are a standardized curriculum alignment across the state schools, reducing duplicate lesson prep effort district-wide. Brisk Teaching in regards to value network and domain. The domain for Brisk Teaching would be the teacher productivity curriculum authoring software, which is layered onto existing Google and Microsoft ecosystems. The value network, freemium teacher acquisition, paid district contracts, distribution by a Chrome web store, and word of mouth. This is also dependent on Google, Microsoft APIs and underlying foundation model providers such as OpenAI and Google. The infrastructure is largely cloud hosted, API dependent, lightweight, with no dedicated hardware, and scalability is tied to large language model API costs and reliability. The brand position is the challenger and insurgent brand, targeting the individual teacher first, then upselling to districts. Brisk Teaching is this fusion, speciation, or convergence. Classification for this would be convergence. It merges AI generation, curriculum standards data, and existing productivity suites, such as Google Docs and Slides, into one workflow, while each underlying technology remains intact. Disruptive potential, moderately disruptive to the traditional lesson planning market and to the slower incumbent curriculum publishers. Now we're going to talk next about our second of 5 technologies we're assessing. This would be the software company GoGuardian, which recently acquired PeerDeck as well. We'll talk about its current state, S-curve, and hype cycle position, and a little background. GoGuardian was founded in 2014. Its core product is K-12 internet monitoring, filtering, and classroom management software. As I mentioned, they acquired PeerDeck in 2020, and it's an interactive real-time digital lesson slide and formative assessment subsidiary. And PeerDeck has more than 14.2 million students that use the lessons in the 2022-23 school year, and this is distributed through GoGuardian's existing school relationships. GoGuardian and PeerDeck have a rapidly accelerated growth as far as the hype cycle is concerned through COVID-19, with all the remote learning taking place in 2020 through 2021, which actually compressed what is normally a multi-year adoption curve. So that was grossly and markedly accelerated due to the circumstances. GoGuardian PeerDeck now supports roughly 25 million students and 2 million educators across more than 10,000 schools, which is about 50% of the U.S. K-12 students. Their hype cycle position: the core GoGuardian platform sits on the slope of enlightenment. There's massive real world adoption, but districts are still working through privacy, filtering, accuracy, and effectiveness concerns. PeerDeck sits in the trough of disillusionment, with visibility propped up by its parents' much larger installed base. GoGuardian PeerDeck innovation adoption curve position, as postulated by Rogers. The innovation adoption curve position: the core GoGuardian platform sits solidly in the late majority, bordering laggards, with roughly 50% of U.S. K-12 students covered. It has moved well past mainstream adoption and into near ubiquity for device-managed districts. PeerDeck, on the other hand, as a subsidiary, occupies the early to late majority range as well, but that position is largely inherited from the parent GoGuardian's distribution network rather than independently earned. This is a bundled product adoption path distinct from a standalone diffusion process. GoGuardian PeerDeck. As I mentioned before, COVID-19 compressed GoGuardian's normal Rogers curve timeline. The pandemic forced late majority and even laggard districts to adopt simultaneously with early majority districts, rather than diffusing gradually over a course of years. The remaining non-adopters are largely laggards, the districts with limited device fleets, minimal one-on-one technology programs, or explicit local opposition to monitoring software. GoGuardian PeerDeck market viability forecasts and applications. It is already market viable and mature. Near term, 12 to 18-month evolution is adding generative AI classroom management, beacon style well-being alerting, and expanded PeerDeck gamification features. Product applications: remote screen monitoring, app site blocking, whitelisting, device locking, GoGuardian Core, interactive slideshows, live polling, and formative checks, which is part of the PeerDeck subsidiary. Process applications are state-level safety compliance reporting, at-risk student early warning workflows, and real-time formative assessment data feeding into the broader student analytics pipeline. GoGuardian PeerDeck value network and domain. The domain would be student safety and device management infrastructure for K-12 IT departments. That's GoGuardian Core, plus interactive presentation and formative assessment software for classroom instruction. The value network, it's sold directly to district IT, CIO offices, and it's often bundled with Chromebook deployments. It integrates well with Google Workspace and device management platforms. And PeerDeck rides on the same 10,000 plus school distribution network as an internal cross-sell rather than an independent go-to-market motion. Their infrastructure is quite robust. The platform processes 2.4 billion browsing events and manages roughly 800,000 classroom sessions daily, including mature enterprise-grade cloud infrastructure shared across both products. Their brand position is that GoGuardian is an established incumbent and market leader in K-12 device safety. PeerDeck functions as a sub-brand riding on the broader institutional credibility of its parent company, GoGuardian. Now, when looking at GoGuardian and PeerDeck, is this fusion, speciation, or convergence? The classification would be convergence. GoGuardian combines web filtering, classroom management, and increasingly AI-driven well-being analytics into one platform without displacing any single underlying technology. Peer Deck represents speciation within that structure, though. It's a specialized presentation-focused branch of the broader GoGuardian family, tuned for interactive instruction rather than monitoring. Their disruptive potential is low new disruption risk for the combined entity, mature incumbent, though exposed to privacy-driven policy disruption. Peer Deck functions as a sustaining innovation for the GoGuardian ecosystem rather than an independent disruptive force. Our next software company and learning platform we're going to speak on is IXL Learning. We'll talk on the current state and the S-curve and hype cycle positions. IXL Learning was founded in 1998 and it did not reach its full adoption until 2007. It was initially a math-focused adaptive learning platform. Now it's spanning multiple subjects and it's evolving more in the recent future and will likely do so into the coming future. It's used by more than 17 to 18 million students in roughly 96 of the top 100 U.S. school districts, with effectiveness research now conducted in all 50 states. The IXL Learning's hype cycle position is that of a plateau of productivity for its core adaptive learning engine, and that's an AI-driven personalized question generation sits on the slope of enlightenment. The S-curve is mature late stage for core product and is renewed growth phase for its newer generative AI question layer. IXL Learning innovation adoption curve position. Their innovation adoption curve position is deep into the late majority. They are approaching full market saturation, and their presence is in 96 of the top 100 U.S. districts, indicates diffusion is essentially complete across large, well-resourced districts. IXL's own history illustrates the full Rogers curve. They were founded in 98, but not fully adopted until 2007. Roughly 9-year diffusion lag, typical of early majority to late majority crossing for institutional education technology. The remaining non-adopters are laggard districts, generally smaller or lower resourced, and they adopt only once the technology is fully de-risked and are often mandated or subsidized. IXL Learning's market viability forecast and applications. It's already market viable and broadly deployed. Near term, 12 to 24 month, likely see expansion and adding new subject areas beyond math and ELA or language arts to its English language arts to its AI curriculum model. The product applications would include adaptive question generation, scaffolded remediation, immediate feedback, English as a second language support in 80+ languages. Process applications, state and district level standards, alignment reporting, and automated intervention and RTI documentation. IXL Learning Value Network and Domain. The domain would largely be adaptive, personalized learning and practice platform for pre-K to 12 mathematics and literacy. The Value Network is sold by direct district licensing, heavily research validated, independent studies across all 50 states, and this builds much trust with school board procurement committees. Their infrastructure is mature with a high throughput, over 200 billion questions answered to date, and they demonstrate enterprise scale battle tested systems. Their brand position is trusted and its research is backed incumbent with low perceived risk for conservative buyers such as the school boards. Now with IXL Learning, is this fusion, speciation, or convergence? We feel it's largely fusion. You have adaptive algorithms with large language model generated question banks layered onto a mature speciation model, which is subject specific tracks, math, English language arts, science, and social studies. Its disruptive potential, it's a low disruption risk to itself. IXL is itself a mature disruptor of legacy paper, workbooks, and practice sets of the past, and still currently used at some points in time. Microsoft Copilot will be the next technology we're going to look at. Its current state is S-curve in hype cycle position. Basically, Microsoft Copilot is an AI layered directly onto existing Microsoft 365 tools that people are getting more and more familiar with over time. Of course, Word, Excel, and Outlook have been around for many years. Teams is evolving and is quite a popular platform. The base productivity suite remains intact and unchanged. Microsoft is embedding Copilot directly into the learning management system environments starting in 2026, extending it from a general productivity tool into an education-specific layer. Their hype cycle position is that of peak of inflated expectations, moving towards the slope of enlightenment as enterprise licensing and district pilots mature. Now on their S-curve, it's early to mid-inflection, and their capability is growing quickly, but district-wide licensing is still rampant. In regards to Rogers Innovation Adoption Curve position, early adopters are expanding into the early majority. Copilot benefits from running on Microsoft 365's pre-existing late majority laggard level saturation in K through 12, but the AI layer in and of itself is only now crossing from an enthusiastic IT departments into the mainstream staff use. Because it's bundled into enterprise agreement districts that are already held, Copilot can potentially skip much of the slow grassroots diffusion that a standalone product like Brisk, for example, must go through. A watch item: staff training and change management capacity, not technical access, is usually the binding constraint, moving Copilot from early adopters to early majority in a district. Microsoft Copilot, in regards to market viability forecast applications, is market viable now for staff productivity, such as lesson drafting and email meeting summaries. Full learning management system integration projected to be market viable within the next 12 to 18 months. Their product applications include lesson plan drafting, email composition, meeting summaries, and IEP 504 documentation support. Their process applications include standardized district-wide administrative task automation and reducing after-hours teacher workload. Microsoft Copilot Value Network and Domain. Microsoft Copilot's domain is enterprise productivity software augmented with generative AI, targeting the office administrative layer of a school district. Their value network is sold to existing Microsoft 365 education enterprise agreements and is deeply integrated with the district's existing IT infrastructure and identity security stack. Their infrastructure is extremely robust. It's built on Microsoft Azure's global hyperscale cloud and OpenAI's foundation models, giving it enterprise-grade reliability and compliance certifications under FERPA and COPPA aligned agreements. Their brand position is that they are a trusted incumbent enterprise vendor, lowest perceived procurement risk of the 5 for a conservative school board. Now, when looking at Microsoft Copilot, is this fusion, speciation, or convergence? We feel the classification is largely convergence. The AI capability merges into existing productivity software without displacing Word, Excel, Outlook, or Teams. The disruptive potential is sustaining rather than disruptive. It extends incumbent tools rather than replacing them. Lastly, we're going to be looking at ChatGPT and cloud. Again, OpenAI is the parent company for ChatGPT, and Anthropic is the parent company for cloud. OpenAI's ChatGPT has speciated into multiple tuned versions. There are consumer grade, enterprise grade, education, which is called ChatGPT EDU. There's a GPT 4.0, a lightweight GPT 4.0 mini, and Anthropic's Cloud combines large context reasoning with constitutional AI safety training. Duke University, for example, issued every undergraduate secure ChatGPT 4 access under a university-managed license, an early proof point for K through 12 speciated deployment models. Hype cycle position. ChatGPT overall sits at the peak of inflated expectations for general use, while ChatGPT EDU and Cloud both sit earlier in K through 12, specifically closer to the innovative trigger, reflecting nascent footprints within governed K through 12 environments. The S-curve, this broad consumer adoption of ChatGPT, has already occurred, but governed K through 12 specific deployment of either model remains in an early growth phase. Looking at ChatGPT Cloud, as far as on the innovation adoption curve position, innovation adoption curve for consumer ChatGPT, again, is well into late majority in the general public, but ChatGPT EDU, specifically within governed K through 12 settings, sits in the early adopters. There's a large gap between general market and institutional K through 12 diffusion curves for the same underlying technology. Cloud sits even further back, firmly within innovators. It's used today primarily by a small number of technically sophisticated central office staff and pilot programs, rather than classroom first, in contrast to ChatGPT's more student-facing pattern. This split illustrates that adoption curves are actually domain-specific, which means that technology can simultaneously be a late majority product in one market and an innovation trigger product in another governed market for the very same underlying technology. Now, crossing from innovators into genuine early adopters for Claude, and from innovators, early adopters into early majority for ChatGPT EDU will depend largely on visible, well-documented pilot wins that other districts can point to as proof of value. ChatGPT Claude market viability forecasts and applications. ChatGPT is a market viable today for pilot tutoring programs and writing feedback initiatives under close teacher supervision, with full learning or LMS embedded deployment projected viable within the next 12 to 18 months. Cloud is market viable now for administrative and policy uses, particularly long document analysis, with classroom-facing student-safe tutoring applications projected viable in 18 to 24 months as K through 12 specific guardrails mature. Product applications, personalized tutoring, writing feedback, research assistance, and long context policy drafting, and safe student interaction. Process applications include standardized AI literacy curricula and co-playing workflows, for example, ChatGPT, and AI policy compliance assistant workflows, reviewing board policy drafts against state and federal regulations as assumed by Cloud. Looking at ChatGPT and Cloud as far as value networks and domains, the domain is general purpose conversational AI, speciated downward into an educational specific tier, ChatGPT, or a safety first long context language modeling targeting regulated enterprise and policy heavy domains, Cloud, a strong natural fit for compliance or sensitive government educational buyers. The value network. OpenAI sells directly to districts and universities via enterprise agreements. This is underpinned by a compute partnership with Microsoft Azure. Anthropic sells via direct enterprise agreements in cloud marketplaces, such as Amazon Web Services, Bedrock, and Google Cloud, with a smaller, less mature K through 12 specific sales motion than OpenAI or Microsoft today. Their infrastructure both depends on hyperscale cloud compute and global GPU or graphics processing unit supply chains. Centralized model hosting raises data residency and privacy questions for a state agency to evaluate carefully. The brand position is that ChatGPT is a category defining but strongly consumer associated requiring active public monitoring and public perception in classrooms. Cloud is a safety and trusted challenger brand, and we have to look into compliance first, pitch to a risk-averse board. Now I'm looking at ChatGPT and cloud. Is this fusion, speciation, or convergence? Under classification, we feel that ChatGPT is a textbook example of speciation. One foundation model branch into consumer, enterprise, and education to environs, and cloud is a clear example of fusion, combining large context reasoning and constitutional AI safety training into a hybrid capability that neither approach could deliver alone. Now, the disruptive potential, we feel ChatGPT is highly disruptive to traditional tutoring and writing feedback vendors, and cloud is potentially disruptive to legal compliance consulting and policy drafting workflows within district central offices. We're looking at some of the S-curve positioning of the 5 EdTech AI solutions. We have Brisk Teaching, GoGuardian, IXL, Microsoft Copilot, ChatGPT. IXL Learning and GoGuardian have been around for quite some time, but they have AI elements that they're stacking on, so we still expect to see more inflection and growth. And you can see with Brisk, GoGuardian, or Brisk, Microsoft, and ChatGPT, we should see some rapid inflection change in the near to intermediate term. This is an example of our Gartner style hype cycle of our 5 EdTech AI solutions. And you can see Brisk Teaching is near the top of the peak of inflated expectations. And our large language model, ChatGPT and Cloud EDU, is also in the peak of inflated expectations, a little further along. Microsoft Copilot as well. You have the trough of disillusionment here. Under slope of alignment, you find GoGuardian, including Peer Deck. Plateau of productivity, you find IXL Learning. This is an example of a Rogers innovation and adoption curve, positioning of the 5 EdTech AI solutions that we're looking at. As we talked before, you have the innovators, your early adopters, your early majority, late majority, and laggards. You can see that the Cloud GPT or ChatGPT and Cloud, it's right at the intersection of innovators to early adopters. Brisk Teaching is firmly within the early adopters, and Microsoft Copilot maybe a little further along. GoGuardian, including Peer Deck, in the early majority, and IXL Learning moving from early majority, likely soon to be into the later majority. Now, this is very important. We're going to look at a technology roadmap, matching emerging tech to current life cycle stage. The bottom line to this is we want the board's core planning challenges to sequence matching the maturity of emerging AI technology to the maturity of the technology currently in place, and then matching the pace of the rollout to who within the state's school system is likely to adopt it at each stage. So we'll talk more about these different timelines in the slides to follow, but tools whose life cycle is mature, such as IXL's core adaptive engine and GoGuardian's filtering platform, both deep and the late majority on the adoption curve, should be augmented. So you see that we'll augment IXL and GoGuardian Peer Deck with Copilot workflows, and we'll pilot Brisk District tools. And 12 to 18 months to integrate ChatGPT, Cloud for policy drafting, compliance assistant. 18 to 24 months, we could deploy Peer Deck gamification by GoGuardian. And assuming the pilot Brisk District tools in the first year works out well, you could have a Brisk full district rollout pending approval. In 2 to 5 years, focus on we recommend replacing aging systems, and we feel that AI teaching assistants based upon fusion and speciation will take hold. And in 5 to 10 years, there'll be new S-curves with personalized AI learning companions and AI integrated operations, but we'll talk more about this in the next few slides. Again, the roadmap logic is that mature current tools such as IXL Core Engine, GoGuardian filtering, you augment now with Copilot and ChatGPT layers within the next 0 to 12 or 0 to 24 months. Aging plateauing tools such as PeerDeck with GoGuardian and static learning management system software content, you'll plan for replacement with Fusion Speciation AI teaching assistants in the next 2 to 5 years. When you have tools meeting needs but facing future obsolescence, such as rules-based compliance checklists or manual IEP documentation, we would likely recommend replacing them with cloud-style long context compliance assistants as they mature in the next 18 to 24 months. Future organizational needs with no current solution, such as fully personalized AI learning companions or AI integrated school operations, these are more longer term, will track as 5 to 10 year new S-curve investments. And as far as adoption curve implication, technology is still in the innovator or early adopters such as cloud, ChatGPT, EDU. They will need to have visible pilot wins before early majority districts will follow. Technologies already in late majority such as IXL and GoGuardian need only incremental augmentation, not persuasion. So in the 0 to 12 month time period, augment what already works would be our recommended strategy. You add and expand, add Microsoft Copilot and Microsoft 365. You staff pilot for lesson drafting, email, meeting summaries, IEP documentation support. And under brisk teaching, we recommend expand teacher level Chrome extension use for curriculum aligned resource creation. Things to maintain would be IXL, no change needed. It's plateaued, it's mature, keeps a core adaptive practice engine, and GoGuardian and subsidiary PeerDeck continue as is, monitor privacy policy developments. In the 12 to 18 month time frame, we recommend integrating and formalizing. So new pilots, we could take ChatGPT EDU and we could integrate that into LMS workflows for tutoring and writing feedback pilots. And we could pilot cloud for AI policy compliance assistant use case, reviewing board policy against state and federal regulations. And things to formalize would be PeerDeck gamification features by GoGuardian, which could be rolled into standard classroom instruction toolkits. Data governance policy could be formalized for any new large language model vendor, retention, training data use, and opt-out. In the 18 to 24 month time period, we recommend scaling and preparing infrastructure. To scale would be brisk district management tools rolled out statewide. You could pilot AI tutoring for targeted student groups, English as a second language, at risk or gifted. And you could prepare with network device infrastructure for on-device or low latency large language models and establish long-term roadmap governance committee for AI enhanced operations school-wide. In the 2 to 10 year time frame, replace and build new S-curve capability. In the 2 to 5 year time frame, you'd want to replace aging systems, and there'll be AI teaching assistants largely composed by process of fusion and speciation that will track mastery, suggest differentiated lessons, and build pacing guides. And there'll be on-device large language models for offline privacy preserving tutoring. That could be also in students' personal computers or based on a school supplied infrastructure that they could log into. You would expect impact across both horizons with reduced teacher burnout, which is key, more consistent differentiation, and better use of assessment data. In the 5 to 10 year time frame, new S-curve technologies such as personalized AI learning companions will be offering long-term individualized learning paths and mastery-based progression. And you'll have AI integrated school operations convergence covering smart scheduling, predictive maintenance, and early warning systems for attendance, behavior, and well-being. Assessing the state school board as an organization. State school boards are elected and appointed public bodies balancing academic policy, budget oversight, and community accountability across the entire state. Decision cycles are slow by design, have public meetings, procurement rules, and multi-stakeholder approval processes, prioritizing deliberation over speed. Cultures are risk averse and equity driven, and any new technology must serve every district from well-resourced suburban systems to under-resourced rural ones, which is key. Assessment sets up following strengths and blind spots analyses, which will inform our next deep dive and review on recommendations for change management and implementation plans. Strengths: strong procurement and vendor vetting processes reduce the risk of chasing hype cycle fads. Statewide scale enables favorable enterprise licensing terms, such as Microsoft 365 Education and IXL district agreements. Establish data privacy and compliance frameworks, FERPA-aligned policies, provide a foundation for evaluating new AI vendors. Existing IT governance committees already bring together technology staff, administrators, board members, and teachers the right structure to evaluate emerging AI tools. And there's a growing recognition that the CIO technology director role now extends into AI strategy, governance, and curriculum collaboration, not just infrastructure. Potential blind spots and weaknesses: slow governance cycles, risk adopting technology only after it becomes obsolete, and at times you can have a reactive rather than proactive planning process. Political and public visibility can cause overcorrection. Boards may avoid promising tools such as Cloud or ChatGPT EDU due to consumer AI brand perception rather than technical merit. Equity gaps between rural and urban resource districts and well-funded districts can widen if AI rollout is not centrally coordinated. And at times, or sometimes often, there's limited in-house AI data science expertise at many state boards, making it difficult to independently verify vendor efficacy claims, such as BRIS's newer generative AI features. There's fragmented ownership, such as curriculum, IT, legal compliance, and HR, often evaluating new technology independently, slowing coordinated decisions and creating blind spots between departments. There's student data privacy litigation risk, such as the ongoing IXL data privacy class action allegations, and this is not always weighted as heavily as instructional benefit during adoption decisions. And boards often mistake a technology's position on the adoption curve for its readiness. So a tool used by many, such as the late majority, is not automatically the best fit. And likewise, a tool used by few, the innovators, is not automatically too risky. Thinking about new technology before implementing it, one has to ask themselves, what are the new technologies? What are they really? So distinguish genuine shifts, such as agentic AI acting autonomously from rebranding existing features. What is the technology's domain and value network? Does it align with our procurement, our security and equity requirements? Is this fusion, speciation, convergence? And does that classification suggest how quickly it will mature or how easily it will integrate with what we already have? Where does this all fit into the adoption curve? And does our organization's risk tolerance match that stage? Innovative early adopters require pilot tolerance. Late majority tools only need typically integration planning. What is the vendor's infrastructure robustness, manufacturing supply chain dependency, compute foundation model access, and financial stability? How does the technology compare to current best practices in the industry? And who has already piloted it in real world proof points? These questions must be addressed at the very start of any adoption project before RFPs are written or pilots are approved. And to segue to the implementation plan, this analysis establishes what technologies exist, where they sit on the S curves, hype cycles, and adoption curves, and how they map into the board's timeline needs. Next, we will address the blind spots identified here directly: governance coordination, pilot design, success metrics, and communication strategy for the board and the public. Our goal is to move the state board from reactive technology adoption to a proactive, forecasted technology roadmap. In closing, it is key to know that we feel secure in stating that AI is not replacing teachers, it is replacing the tasks that keep teachers from teaching. The 5 technology families reviewed here today sit at different points on the S curve, hype cycle, and adoption curve, but each has a role to play on a coordinated 12, 18, or 24-month to even a 5 to 10 year roadmap. Districts and state boards that plan now, matching new technology to the life cycle and adoption stage of what they already have, will reduce the workload for teachers, will improve student outcomes, and modernize operations ahead of the next wave of disruption. These are references that we reviewed and perused prior to making this presentation. And as far as speaking for Team 3 at UAT, much thanks for watching this video. And any questions can be directed to any of our team members. Thank you very much.